Runways and taxiways take a beating. Every day, they bear the weight of aircraft under high tire pressures and often intense heat. Over time, that stress can cause rutting, which compromises safety, drainage, and pavement life. For decades, airfield asphalt mix designs have been based on volumetric criteria, air voids, binder content, aggregate structure. These are helpful measures, but they don't always predict how a mixture will hold up under real-world conditions. That's where Balanced Mix Design, or BMD, comes in. BMD goes beyond the recipe. It uses mechanical performance tests to directly verify that a mixture can resist the distresses it will face in the field.
BMD, it's basically a philosophy. We're trying to move away from a design based on the traditional volumetric mix design and try to focus more on the mechanical tests and the distresses that are of interest to the pavement where that mixture is going to be applied.
It's a huge deal to bring BMD to airfields. The FAA specifications have not included these performance tests in the past, and with the BMD, we'll be able to assure better performance with a more reliable system.
BMD has already proven itself on highways. Now, the Airport Asphalt Pavement Technology Program, AAPTP, a cooperative agreement between the FAA and NAPA, is bringing it to airfields. A research team led by the University of Nevada, Reno, with partners at Rutgers University, Texas A&M Transportation Institute, RDM International, and Duval Engineering, set out to identify the best rutting performance tests for airfield asphalt mixtures. The team collected asphalt samples from active airfield projects across multiple states, representing a real range of materials and production conditions. From there, they evaluated 4 test methods for reliability, repeatability, accuracy, and practical use. The Asphalt Pavement Analyzer simulates repeated wheel loading under dry conditions at 2 pressure levels that reflect the range of airfield loading. The Hamburg Wheel Tracking Test evaluates rutting and moisture susceptibility under submerged conditions and has a strong track record correlating with field performance. The High Temperature Indirect Tensile Test, or HTIDT, and the Ideal Rutting Test, or Ideal RT, are faster index tests. They are practical options that can be run during production to provide quick performance feedback.
The challenge with the other rutting tests is you fabricate samples, you take them to a lab that to be conditioned, they run for a long period of time. So the index tests are really going to be a good tool to quickly get an answer, or at least an indication of the anticipated performance.
The lab findings were validated against real-world performance. The team obtained cores from airfield pavements that were performing well and from sections experiencing rutting and checked them against the criteria developed in the lab. The findings are designed to inform updates to FAA specifications, with new test criteria tailored to environmental conditions, aircraft loading, and the specific area of the airfield being paved, whether runway, taxiway, or apron.
Any improvement that you do on the mix and then you extend the life of the pavement, that's going to delay the maintenance activities. And by delaying the maintenance activities, even by just 1 year, there's going to be a lot of cost savings.
The findings support a gradual transition to performance-based specifications, improving pavement performance and extending service life.